again 1.6. This is page 35 in your book. We're going to look at some functions today, and key vocabulary. There's quite a few over there on the side if you look at with me on in your book. And you can, these are what you write with me, the vocabulary. And I'll try to remember to do the best. Whoops, that was supposed to be a straight line. Not very good, was it? Here, let me see if I can do better. Won't let me erase it. Let me see if I can get a better line. How about like this? Straight down like that. That's better. So a function, if you guys will read along with me, I'm on page 35, and this is a good, just listen to this. It says, when you pump gas, the total cost depends on the number of gallons pumped. So your total cost is a function. It's depending upon how much gas you got. So functions are made up of, they consist, and you can put this, functions consist of a domain and a range. Okay, the domain are what we call the inputs. Sorry again. The inputs, and the range is the outputs. So as far as the gas goes, the input would be how much gas are you putting in. The output then would be the total cost for your gas. Okay, so we'll do some functions, we'll make some tables, and hopefully you'll kind of catch on to what those are. When we get into functions, we also have the independent variable and the dependent. The independent variable is the input, and the dependent variable is the output. And let's go back to the gasoline. The independent variable is the number of gallons of gas. 1 gallon, 2 gallon, 3 gallons. The dependent, the price you pay for the gas depends on how much gas you put in there, the output. So the output then would be, depends on your input. If the gas costs $2 a gallon, you put in 1 gallon, your cost is 2. You put in 2 gallons, it's 4. So your independent variable in this case or your dependent variable, excuse me, depends on what your independent variable does. So we'll do a few examples and go through those. So example number 1, identify the domain and range of a function. The input-output table shows the cost of various amounts of regular unleaded gasoline from the same pump. Identify the domain and the range of the function. So remember, we just wrote them in our vocabulary. Input and output, the input in gallons and the output. So in this case, these numbers right here are the domain. Okay, those are the independent variables. These are this is the range, and those are the dependent. So our price depends on how much gas we put in. We put in 10 gallons of gas. Our cost is $19.99. We put in 12 gallons of gas, $23.99, and so on. So let's see what. Okay, so the domain is the set of inputs. Notice I wrote that on top. The range is the output. So we're just right now identifying inputs and outputs, domains and ranges. So on the guided practice here, it says identify the domain and the range of this function. So this is called a function table. Our inputs and our outputs. Well, the inputs are the domains. I'll just put a line. Those are the domains. The ranges are these numbers. So we would go like this. The domain. And if you're writing these in on an answer sheet, you would put 0, 1, 2, and 4. And you would put the range is 5, 2, 2, and 1. That's it. Identify the domain and the range. And then put 2 twice. I guess we don't really have to. It's just once. It's still the same number. So we go to the next slide and talks about identifying a function. What is a function? So it says tell whether the pairing is a function. So this is called this is an input output. I try to think of it this way, that this is that you like have a machine. Okay, you have a machine right here. Okay, and at the top there's this little funnel, and you drop a number into the machine. And then over here, there's this little chute that slides out the number. This number slides out of the machine. So let's say we drop in a 0. We put in 0, something happens to it inside here. It spits out, it becomes a 2. We drop in a 5. We spit it out, it becomes a, well, here's another lane. We drop in the 0, it becomes a 3. But whatever it does the exact same thing every single time. So for every input, there's only one output. So 0, in this case, has 2 as an output, and it has 3 as an output. That's not possible. We dump it into the same machine, it does the same thing to it. We can't put a 0 in the machine and have it spit out a 2, and then put a 0 in the same machine that does the same exact thing and have it spit out a 3. If we put in the same number, it would spit out the same number. So out the same number as it did before. So it should be spitting out the 2. So on A, we would say in this case that this is not a function because 0 cannot have 2 different outputs. 5 going to 4, that's fine. 10 can become a 5, that's fine. But you can't have 0 be 2 different numbers. So that would be not a function. Okay, and there's their explanation. So let's check out another one. So on B, all right, so we put in a 0, we get out a 0. That's all right. Right here, if I can. Okay, we put in a 0, we get out a 0. We put in a 1, we get out a 2. We put in a 4, we get out an 8. We put in a 6, we get out a 12. Yep, there's not, 0 didn't have, this 0 didn't, we didn't put in another 0 and get out a different number, so we would say yes, that is a function. That works. Every input has 1 and 1 output, and that works good. So we say yes. Okay, so in the guided practice, let's practice on this one. So we put in a 3 in our little machine. I can find my, we put in a 3, we get out a 1. We put in a 6, we get out a 2. We put in a 9, we get out a 2. We put in a 12, and we get out a 1. Is that a function? Now remember, the inputs can have just one output. They don't, it's okay to share an output. These two can have the same output, that's fine. We just can't put the same number in and get 2 different numbers. But we definitely can do it this way. So we would say on this case that, yes, this is a function. So the next one, tell whether this is a function. Okay, we put in a 2 and we get out a 0. We put in a 2 and we get out a 1. Put in a 4, get out a 2, a 7. Now these are fine, but over here's our problem. In our machine, you can't drop a 2 into the machine and get a 0, and then drop a 2 in the machine again and get a 1. Something's wrong there, so that is not a function. An input, these inputs, cannot have 2 different outputs if those inputs are exactly the same. That is not possible. So not a function. Okay, so it says, make a table for a function. Example number 3. It says, and actually there is a key concept box above example 3 that it shows you making a table. It gives it to you as a verbal rule and as an equation, and then makes a table. So we'll just do this here in example 3. We have a function. We have this equation, y equals 2x. The domain of the function, and in this case we have x's and y's. We're going to make, I like to make my tables, and it's total preference, I like to make my tables going up and down like this. I don't like to put them across. So in this case it says the domain of the function is 0, 2, 5, 7, and 8. And the domain, I always give the domain x, so 0, 2, 5, 7, and 8. They're telling me what x is. So now all I do to find the ranges is I substitute that in to the problem. So 0 times 2 times 0 is 0, 2 times 2 is 4, and see, all I'm doing is substituting them in over here and doing the algebra. 5 times 2 is 10, 7 times 2 is 14, 8 times 2 is 16, and then we're good to go. That is my table for the function. Then identify the range of the function. So the range, I have to identify it, so I have to write it. The range is 0, 4, 10, 14, and 16. And those ones aren't coming out very good, but not too bad. I'm writing better with this pen. And I wrote all over it, but you'll notice they're substituting the numbers in, and they came up with the same numbers that we did. Okay? So write a rule for the function. So this case, I got to figure out what am I doing to the input to get the output. So the rule, if you look, what I do is I just try to say, what do I do to this number to get this number? What do I do to the, and it has to be the same for each one. What do I do to this number to get this? So what do these all have in common if you look from this one to this one? You notice 2, add 2, add 2, add 2. So our inputs are x's, okay? Our outputs are y. So y equals x x plus 2. Pretty cool. That's our rule. It's just, in other words, it's kind of like writing an equation. Okay. So example number 5, concert tickets. It says you are buying concert tickets that cost $15 each. You can buy up to 6 tickets. Write the amount in dollars you spend as a function of the number of tickets you buy. Identify the independent and the dependent variables. Then identify the domain and the range of the function. So we can write in the amount in dollars we'll spend as a function of the numbers of tickets that we're going to buy. So write a verbal model. N is going to represent the number of tickets, so we can do, every ticket costs us $15, so 15 times N equals the amount we're going to spend. Okay, so we could buy 0, 1, 2, 3, set up to 6 tickets. So check this out, we make a table of 0 through 6. 0 tickets cost us $0. I'm looking right here, 0 tickets cost $0. 1 ticket's 15, 2 tickets are 30, 3 tickets are 15 or 45. Notice up here you're just taking the number of tickets times 15 to get the dollars. Okay, so there's our table to identify the range. The range is right here. Okay, so we would write range and you would write all those numbers down. Then there's writing them down. Okay, and then we didn't talk about it. The independent variable is the number of tickets, and then the dependent variable is the amount of dollars, because remember, the money we spend depends on how many tickets we buy. So that's our independent number of tickets, and dependent variable was the amount in dollars. So number 4, make a table for the function y equals x minus 5 with the domain of 10, 12, 15, 18, and 12. Or excuse me, and 29. So I always just write the, okay, I'm going to write the function over here, and I'm going to make myself a table. I see x and y, and my tables are going to go up and down because that's just the way my brain works. There's 10, 12, 15, sorry, 15, at 15, 18, 29. Okay, so we just substitute. It says identify the range, so we put in this number. We want to put this 10 in right here. 10 minus 5 is 5. 12 minus 5 is 7. 15 minus 5 is 10. Excuse me. 10 minus 5 is 5. 12, yeah, I did 12 minus 5. Eesh. 18 minus 5 is 13. Sorry, my brain forgot what was happening there. 29 minus 5 is 24. So you guys think you're the only ones whose brain don't work when you do math. Notice it happens to me. So I range, when it says identify the range, I would go range equals 5, 7, 10, 13, 24. And I probably, see if they solved it, I probably wrote all over it. Yep. So the number 5 on the guided practice says write a rule for the function and identify the domain and the range. So time in hours and your pay in dollars. So this would be like you work 1 hour, you get $8, 2 hours, 16, 3 hours 24, 4 hours 32. Well, if you know your multiplication facts, this should be pretty obvious. To get from this number to this number, it's looking like you're making $8 an hour to me. 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. 4 times 8 is 32. So our pattern right here is in the time, the number of time, which is hours. Every hour you work, you get $8. So 8 times H equals D, your number of dollars. So there's my rule and my domain. The domain, stop, is 1. Wow, I'm going to have to ask Mrs. Starkeybaum to help me with this pen. 1, 2, okay. I'm not going to write them here. You guys can, the domain is right there, and the range, that's making me laugh. That's the only thing I can do is laugh, because otherwise I'd be mad. The range is right there, those numbers, 8, 16, 24, 32. So go ahead and write those out, even though I can't write it out with my crazy pen. All right, I think, and they just used X and H, and we used X. You know, we can use X and Y. You can do whatever you want. So that's it for 1.6. Please ask if you have questions. Sometimes these can be kind of tricky. See you next time.